Element 55 on the periodic table of elements is known as cesium. This is Norris Teaches Science with me, Mr. Norris. This is a physical science edition video in the physics section of physical science. Today we're going to talk about magnetic force. The goal for this video is I can discuss how magnetic forces are created in the interacting with each other in the surroundings. It seems like I can't read today. I'm good. Let's continue on. Magnetic force is the force of attraction or repulsion between two objects. All right, but we're going to deal with magnetic poles with this. And I just mentioned it, magnetic poles. There are two poles on a magnet. All magnets have two poles. You have a north pole and a south pole. Magnetic forces go from the north pole to the south pole in most magnets. And the magnetic forces are strongest at the poles. And if you didn't know, the Earth is a giant magnet. The magnetic field surrounds the magnet and exerts a force on other magnets and objects made in the material. So you can see these magnetic field lines on this magnet, kind of indicating them. They're going from north to south pole. Now, when we talk about magnets in attraction and repulsion, the same thing applies like when you talk about electrical charges. Opposites attract and likes repel. Opposite poles will attract and come together. So a north pole is attracted to a south pole. But in repulsion, like poles repel each other. So a north pole will repel another north pole, while a south pole repels another south pole. Now, sometimes it happens. In my classroom, we're messing with magnets, and someone ends up dropping it, and they break it, and they're trying to hide it from me. It's all right, because when you split a magnet, you just make more magnets. Each magnet has to have a north and south pole. So when this first magnet split, the opposite side of the north became the south, and the opposite side of the south became the north. All right, and you can keep splitting it, but the thing is, you kind of decrease the power of the magnet as you do it. Now, magnetic domains are really important. It's a group of atoms with aligned magnetic poles in the same direction. So all the poles in the same direction, all the north poles pointing one way, all the south poles pointing another way. It's really important that this happens, and this is actually part of the way you can make materials in what we call temporary magnets, which is a process which is called magnetic induction. And this is how we make temporary magnets, mainly temporary. It's done by aligning the magnetic poles or domain. So this is how it happens. You take a metal object, and you take a magnet, and you stroke the magnet in the same direction on the metal object, not back and forth, one direction. If you do it enough, the metal object will become a magnet. And so this child is doing this to this nail. It's going to make it so she can pick up the smaller nail over here. You can also use electricity and make a magnet, and that is called an electromagnet. This is when you have a solenoid, which is looped wire around a core, and is a ferromagnetic core, which ferro means iron. So around an iron core. You usually use an iron nail. And so for electromagnet to make a very simple one, you need a nail, you need a battery, and you need a wire. And you're going to wrap the wire around the nail to connect the two ends of the wire to the battery, and your nail is now an electromagnet. And electromagnets are really important in your life, and we're going to get into that in another video. A solenoid, just like I talked about, is a coil of current carrying wire that produces magnetic fields, acts as loops, and it acts like a bar magnet, so it has a north and a south pole. Now, the strength of electromagnet. You can make an electromagnet, but there's a couple things that factor into how strong the electromagnet is. Increasing the current will increase the strength. The more turns of the wire increases the strength of the electromagnet, and making sure you use an iron core will increase the strength. And just so you know, a way that electromagnetic electromagnets work in your life are those automatic door locks. You press a button and you can lock a door on your car. Well, that's a little bit about magnetic force. I'm going to do another video about electromagnetic forces in your life. But I hope you learned something today. I'm Miss Norris, and I am out for this video.